Hi, in this video we're going to focus on solving base E and natural logarithmic equations. Specifically, at the end of the video you should be able to solve base E equations and natural logarithmic equations, specifically equations that have base E or ln only on one side. Let's start with your vocabulary. Remember, natural logarithm, a logarithm with base e, which is actually in symbol ln from a Greek abbreviation logarithmus naturali, ln. Natural base is actually the number e, which I will show you later on the Desmos calculator, which is found using this expression 1 plus 1 over n raised to n, which is true for a huge number of n. Natural base exponential function is an exponential function with base e, or basically it's an exponential function with Euler's constant and it has a power. Next, natural logarithmic function is the inverse of the natural base exponential function. So we're going to deal with inverses of the natural exponential base function, which is going to be a switch between logarithm base e, ln, or e raised to an exponent equations. Now, this lesson is gonna start with a series of review before we jump into solving actual base e exponential equations and the natural logarithmic equations, which is only on one side and the other side is a number. We can also use your Desmos calculator. First part of the review is evaluating your base e. Evaluate, it says here, use calculator to estimate e raised to 0.5 to 4 decimal places. E to the power of 0.5. So let me show you. Amazingly, the Desmos calculator is very smart. If you type E, it actually gives you right away the value of the Euler's constant, which is the E. And we just type in I will use shift 6 because it will become the power, and I will type 0.5, which was the problem on your number 1 first series of review questions. The answer is 1.6487 because your exercise only requires 4 decimals, and actually most of the problems and worksheets will need 4 decimals. It's 1.6487. Okay, to give you a heads up also, it also recognizes ln, but there is an exclamation point. Function ln requires an argument. Remember, argument is the number after the logarithm. So we need a value. For example, try typing ln of x. X is the number we need, let's say 10. And it will give you the value of ln 10 is actually 2.3025 and so on. Okay, let's go back to your PowerPoint. So I forgot the value of e to the power of 0.5, but here it is. It's 1.6487. Using the same calculator technique, e raised to negative 8 should have the value of 0.003. Let's check one more time. E to the negative 8. E shift 6 negative 8, and it's in scientific. The 3 is actually 4 digits away. Let's see. Oh, it's because this is a scientific calculator, so it is shown in scientific notation, but actually 3 is 4 spaces away from 0. That's why it's 0.0003. There's one more thing. Actually, when you click function, the Euler's constant formula is here, and the ln is here, and the logarithm is here. It's on when you press function. By default, when you open the Desmos scientific calculator, it does not show the logarithms, but when you click function, here they are. Okay, you also have only the e and your exponential and your roots function. Let's go back. So let's proceed. That's why I showed ln. So you have ln3 showing using your calculator. ln3 should be, I just type in ln3 and it's 1.0986, and it is. ln1/4 is negative 1.3863. Experiment with your Desmos calculator. Now we also have to review writing equivalent expression. Remember, this exponential can be written in logarithmic form. Actually, this is logarithm base e of 23 is equal to x. And remember, logarithm base e is simply written as ln. So you have ln 23 is equal to x. If you want to find the value of x, remember you can use your Desmos calculator. Okay. Now, as a shortcut, we don't have to undergo the logarithm base e. This is right away ln 6 is equal to x. Otherwise, if you get lost, remember e becomes a base of the logarithm. 23 is the argument, x is your exponent. E disappears because we did a shortcut, because ln of e, base e, logarithm of base e, logarithm base e becomes ln. 6 is the argument, x is the exponent. Okay. How about ln? ln of x is equal to 1.2528. We are going to write it in exponential equation. So this is a little tricky. This is supposed to be logarithm base e of x, and e has a power of 1.2528 equal to x. X becomes exponent. X is the argument, the value of the exponential expression. This is the exponent. ln has a base e because of the logarithm base e, so there it is. This one, number 8, it should be e to the power of 2.25 equal to x. Okay, we are still reviewing. We are not yet on solving. So this is how you rewrite ln to base e exponential equations. Next, before we solve the base e equations and natural logarithm equations, remember inverse properties that we need to remember when we solve. Same as normal logs, logarithm base e of e is actually the same as ln of e, which are both equal. Also, e to the power of ln is equal to the first values, and also e ln, if it shows logarithm base e, it's the same. These all expressions are all equal because they are all equal to 1. What does this mean? If you have a problem e raised to ln of x, it's actually equal to 1. The answer, you can cancel it. The answer is the value or the argument x. Same as ln of e to the x, we cancel ln and e because it's equal to 1. The answer is x. Always remember, by inverse properties, we can cancel either of these when you see them because they are all equal to 1. Okay. Now, we are not yet on solving. Let's now evaluate. So, how do you evaluate this expression? E raised to ln raised to 21, we cancel. Answer is 21. Evaluate e raised to ln with a parenthesis x plus 3. It does not matter. You can cancel it. The value of the expression is x plus 3. How about ln of e? Well, it's logarithm base e is equal to 1. The answer is the exponent x squared minus 1, the power. Same goes here. The expression is equal to 7. Just remember, if you see this expression, they get cancelled, the argument or the power is the answer. We are now ready to solve base E equations. Of course, you can use a algebra calculator, but since we are supposed to use Desmos, we will do manual work beforehand. So we will solve e to the power of x is equal to 10. Before that, remember, there's one more property that we need to recall. If x is equal to y, then ln of x is equal to ln of y. This is actually the reverse of one-to-one property. If we can cancel ln on both sides, we could also do the reverse. We can put logarithms on both sides. That is by one-to-one property. So how can this work? Well, we can actually put ln on both sides at the beginning of each expression by one-to-one property. How does this help? Well, remember, this is equal to 1. The expression is equal to x. And now we can use your Desmos calculator to solve ln of 10. ln of 10 is actually 2.3026. Always remember, use your Desmos calculator. Let's try another. Here, we need to perform some properties of equation. We need to take out 4 here by subtraction. Subtract both sides by 4, 10 becomes 6, 4 cancels out. Now we can actually divide both sides by 3. 6 becomes 2. What is left here is e raised to negative 2x. And we are now ready to apply your writing ln on both sides. And this becomes equal to 1. The expression is equal to negative 2x after cancelling because they are inverse of each other. It's equal to 1. This left side becomes negative 2x. Okay, you cannot divide right away, but you can in a fraction form, but you have to solve first ln of 2. ln of 2 is actually 0.6931 using your Desmos calculator. Then you can now divide. You cannot divide 2 of the number 2 here. You have to evaluate ln before dividing both sides by negative 2. And x is equivalent to negative 0.3466. Notice that it's a wavy. It's equivalent. It's because this is not the actual value. It's just an approximate. Because of the value of the logarithm base e, the e is not an exact value if you write it in decimals. To give it an exact value, you use e, but since we are not gonna stick to have e and we multiply or operated the e, we have approximate value, so we use this symbol to say it is an approximate value, not the exact value. Okay, let's have another. We are now on problem 15. To start, we can take out 5, minus 5 on both sides, 15 becomes 10. Divide both sides by 2. We can divide this by 2 because there's no ln, so this becomes 5, 2 cancels. And now we are going to apply your one-to-one property. We can write ln on both sides. ln of e becomes 1. You have negative 2x on the left side. Evaluate ln of 5. It's 1.6094. Divide by negative 2, and that's your answer. Again, it's approximate, not the exact. Notice that there's 4 decimals because most of the worksheets or tests, if it's going to be actual, approximate, or solved value, we use 4 decimals. Let's proceed. Now, how about solving natural logarithm equation? Look at your problem. Solve ln of 3x is equal to 0.5. Before that, remember, if x is equal to y, we could actually make x and y exponent of any variable, but since we're dealing with natural logarithm and base e, we can use e as the same exponent. That is the reverse of exponentiation. Remember, when we have the problem of exponential equation, we can cancel the same base. Well, this is the backwards, and it's called exponentiation. This is what we're going to apply to solve ln, or natural logarithm equation. So what do? We will actually make both equations. Why? Well, remember, this cancels out by the inverse property. This is actually equal to 1, and the left side becomes 3x. We also have a review of this at the beginning of the video. Use your Desmos calculator. E raised to 0.5 is 1.6487. You're done after dividing both sides by 3, and x is found 0.5496. Interesting, right? Notice we were solving base e equations and natural logarithm equations where one side is a number, the other side is the base e, or the natural logarithm. If both sides has a natural logarithm or both sides has the same base, we can just simply cancel them by one-to-one property. If the other side is only a number, this is how the work goes. Let's continue, we're almost done. Solve ln of 2x is equal to 0.7. By exponentiation, we will raise both sides by they become powers of e. The left side, e raised to ln, cancels. The expression becomes 2x. Evaluate e raised to 0.7 using your Desmos calculator. It should be 2.0138. After that, you divide by 2 and you got your approximate value of x, 1.0069. Let's have some more. Solve ln of 2x minus 3 is equal to 2.5. The same deal, we will make both sides power of e by exponentiation property. Cancel e raised to ln, the expression becomes 2x minus 3. And then evaluate e raised to 2.5. You have 12.1825. Add both sides by 3. This becomes 15, sorry. 12 plus 3 is 15. Divide both sides by 2. It's 7.5912. That is the approximate value of x in this natural logarithmic equation. And this is supposed to be the last. Solve ln of x minus 3 is equal to 3. By exponentiation, both sides becomes power of e. Cancel e and ln. The left side becomes x minus 3. Evaluate e to the power of 3 using your Desmos calculator. It's 20.0855. Add both sides by 3. It's 23.0855. And that's it. You should have learned how to solve base e equations and natural logarithm equations where one side is a number. If you need to review, you can watch this video again. Thank you.